The Yellowstone Caldera is the volcanic caldera and supervolcano located in Yellowstone National Park in the United States, sometimes referred to as the Yellowstone Supervolcano. The caldera and most of the park are located in the northwest corner of Wyoming. The major features of the caldera measure about 34 by 45 miles. The caldera formed during the last of three supereruptions over the past 2.1 million years. First came the Huckleberry Ridge eruption 2.1 million years ago, which created the Island Park Caldera and the Huckleberry Ridge Tuff. Next came the Mesa Falls eruption 1.3 million years ago, which created the Henry's Fork Caldera and the Mesa Falls Tuff. Finally came the Lava Creek eruption 640,000 years ago, which created the Yellowstone Caldera and the Lava Creek Tuff. Volcanism. Volcanism at Yellowstone is relatively recent, with calderas that were created during large eruptions that took place 2.1 million, 1.3 million, and 640,000 years ago. The calderas lie over a hotspot where light, hot, molten rock from the mantle rises toward the surface. While the Yellowstone hotspot is now under the Yellowstone Plateau, it previously helped create the eastern Snake River Plain through a series of huge volcanic eruptions. The hotspot appears to move across terrain in the east-northeast direction, but in fact the hotspot is much deeper than terrain and remains stationary while the North American plate moves west-southwest over it. Over the past 18 million years or so, this hotspot has generated a succession of violent eruptions and less violent floods of basaltic lava. Together these eruptions have helped create the eastern part of the Snake River Plain from a once mountainous region. At least a dozen of these eruptions were so massive that they are classified as supereruptions. Volcanic eruptions sometimes empty their stores of magma so swiftly that they cause the overlying land to collapse into the emptied magma chamber, forming a geographic depression called a caldera. The oldest identified caldera remnant straddles the border near McDermott, Nevada, Oregon, although there are volcaniclastic piles and arcuate faults that define caldera complexes more than 60 km in diameter in the Carmacks group of southwest central Yukon, Canada, which are interpreted to have formed 70 million years ago by the Yellowstone hotspot. Progressively younger caldera remnants, most grouped in several overlapping volcanic fields, extend from the Nevada-Oregon border through the eastern Snake River Plain and terminate in the Yellowstone Plateau. One such caldera, the Brunei-Jabaj caldera in southern Idaho, was formed between 10 and 12 million years ago, and the event dropped ash to a depth of 1 foot 1,000 miles away in northeastern Nebraska and killed large herds of rhinoceros, camel, and other animals at Ashfall Fossil Bed State Historical Park. The USGS estimates there are 1 or 2 major caldera-forming eruptions and 100 or so lava-extruding eruptions per million years, and several to many steam eruptions per century. The loosely defined term supervolcano has been used to describe volcanic fields that produce exceptionally large volcanic eruptions. Thus defined, the Yellowstone supervolcano is the volcanic field which produced the latest 3 supereruptions from the Yellowstone hotspot. It also produced one additional smaller eruption, thereby creating West Thumb Lake 174,000 years ago. The 3 supereruptions occurred 2.1 million, 1.3 million, and 640,000 years ago, forming the Island Park Caldera, the Henry's Fork Caldera, and Yellowstone calderas, respectively. The Island Park Caldera supereruption, which produced the Huckleberry Ridge Tuff, was the largest and produced 2,500 times as much ash as the 1980 Mount St. Helens eruption. The next biggest supereruption formed the Yellowstone Caldera and produced the Lava Creek Tuff. The Henry's Fork Caldera produced the smaller Mesa Falls Tuff but is the only caldera from the Snake River Plain Yellowstone hotspot that is plainly visible today. Non-explosive eruptions of lava and less violent explosive eruptions have occurred in and near the Yellowstone Caldera since the last supereruption. The most recent lava flow occurred about 70,000 years ago, while a violent eruption excavated the west thumb of Lake Yellowstone around 150,000 years ago. Smaller steam explosions occur as well. An explosion 13,800 years ago left a 5 km diameter crater at Mary Bay on the edge of Yellowstone Lake. Currently, Volcanic activity is exhibited via numerous geothermal vents scattered throughout the region, including the famous Old Faithful geyser, plus recorded ground swelling indicating ongoing inflation of the underlying magma chamber. The volcanic eruptions, as well as the continuing geothermal activity, are a result of a great cove of magma located below the caldera's surface. The magma in this cove contains gases that are kept dissolved only by the immense pressure that the magma is under. If the pressure is released to a sufficient degree by some geological shift, then some of the gases bubble out and cause the magma to expand. This can cause a runaway reaction. If the expansion results in further relief of pressure, for example, by blowing crust material off the top of the chamber, the result is a very large gas explosion. According to the analysis of earthquake data in 2013, the magma chamber is 80 km long and 20 km wide, and is shaped like 4,000 km 3 underground mass, of which 6.8% is filled with molten rock. This is about 2.5 times bigger than scientists had previously imagined it to be, approximately the same size that Yellowstone's magma chamber was during its last major eruption. However, some scientists believe that the proportion of melt is much too low to allow another supereruption. Earthquakes. Due to the volcanic and tectonic nature of the region, the Yellowstone Caldera experiences between 1,000 and 2,000 measurable earthquakes a year. Most are relatively minor, measuring a magnitude of 3 or weaker. Occasionally, numerous earthquakes are detected in a relatively short period of time, an event known as an earthquake swarm. In 1985, more than 3,000 earthquakes were measured over several months. More than 70 smaller swarms have been detected between 1983 and 2008. The USGS states that these swarms could be caused more by slips on pre-existing faults than by movements of magma or hydrothermal fluids. In December 2008, continuing into January 2009, more than 500 quakes were detected under the northwest end of Yellowstone Lake over a 7-day span, with the largest registering a magnitude of 3.9. The most recent swarm started in January 2010 after the Haiti earthquake and before the Chile earthquake. With 1620 small earthquakes between January 17, 2010 and February 1, 2010, this swarm was the second largest ever recorded in the Yellowstone caldera. The largest of these shocks was a magnitude 3.8 on January 21, 2010 at 11:16 p.m. Mountain Standard Time. This swarm reached to background levels by February 21. On March 30, 2014, at 6:34 a.m. Mountain Standard Time, a magnitude 4.8 earthquake struck Yellowstone, the largest recorded there since February 1980. Volcanic hazards. The last full-scale eruption of the Yellowstone supervolcano, the Lava Creek eruption which happened nearly 640,000 years ago, ejected approximately 240 cubic miles of rock, dust and volcanic ash into the sky. Geologists are closely monitoring the rise and fall of the Yellowstone Plateau, which measures on average 0.6 inches yearly, as an indication of changes in magma chamber pressure. The upward movement of the Yellowstone caldera floor between 2004 and 2008 almost 3 inches each year was more than 3 times greater than ever observed since such measurements began in 1923. From midsummer 2004 through midsummer 2008, the land surface within the caldera moved upward as much as 8 inches at the White Lake GPS station. By the end of 2009, the uplift had slowed significantly and appeared to have stopped. In January 2010, the USGS stated that uplift of the Yellowstone caldera has slowed significantly, and that uplift continues but at a slower pace. The U.S. Geological Survey, University of Utah and National Park Service scientists with the Yellowstone Volcano Observatory maintain that they see no evidence that another such cataclysmic eruption will occur at Yellowstone in the foreseeable future. Recurrence intervals of these events are neither regular nor predictable. This conclusion was reiterated in December 2013 in the aftermath of the publication of a study by University of Utah scientists finding that the size of the magma body beneath Yellowstone is significantly larger than it had been thought. The Yellowstone Volcano Observatory issued a statement on its website stating, "Although fascinating, the new findings do not imply increased geologic hazards at Yellowstone, and certainly do not increase the chances of a supereruption in the near future. Contrary to some media reports, Yellowstone is not overdue for a supereruption. Other media reports were more hyperbolic in their coverage. A study published in GSA Today identified 3 fault zones that future eruptions are most likely to be centered on. 2 of those areas are associated with lava flows aged 174,000 to 70,000 years, and the third area is a focus of present-day seismicity. Hydrothermal explosion hazard. Studies and analysis may indicate that the greater hazard comes from hydrothermal activity which occurs independently of volcanic activity. Over 20 large craters have been produced in the past 14,000 years, resulting in such features as Mary Bay, Turbid Lake, and Indian Pond, which was created in an eruption about 1300 BC. In a 2003 report, USGS researchers proposed that an earthquake may have displaced more than 77 million cubic feet of water in Yellowstone Lake, creating colossal waves that unsealed a capped geothermal system leading into the hydrothermal explosion that formed Mary Bay. Further research shows that earthquakes from great distances do reach and have effects upon the activities at Yellowstone, such as the 1992 7.3 magnitude Landers earthquake in California, unregistered trademark Esma Jave Desert that triggered a swarm of quakes from more than 800 miles away, and the 2002 7.9 magnitude Denali Fault earthquake 2,000 miles away in Alaska that altered the activity of many geysers in hot springs for several months afterward. Yellowstone Hotspot origin. The source of the Yellowstone Hotspot is controversial. Some geoscientists hypothesize that the Yellowstone hotspot is the effect of an interaction between local conditions in the lithosphere and upper mantle convection. Others suggest a deep mantle origin. Part of the controversy is due to the relatively sudden appearance of the hotspot in the geologic record. Additionally, the Columbia basalt flows appeared at the same approximate time, causing speculation about their origin. See also, Iceland hotspot and Iceland plume describes aspects of volcanic processes, Long Valley Caldera, False Caldera, La Garita Caldera, examples of other calderas close to but not related to Yellowstone. References. Further reading, Breeding, Greg. Supervolcano, The Ticking Time Bomb Beneath Yellowstone National Park. St. Paul, Minnesota, Voyager Press. ISBN A978-0-7603-2925-2. A popularized scientific look at the Yellowstone area's geological past and potential future. Vazes, J.A. Reed, M.R. Timescales of magma storage and differentiation of voluminous rhyolites at Yellowstone Caldera. Contributions to Mineralogy and Petrology 144, 274 Euro 285. Bibcode 2002 Comp 144 274 V doi 10.1007 per second 00410-002-0400-7. Sutherland, Wayne. Sutherland, Judy. Yellowstone Farewell. Spur Ridge. A novel looking at an eruption in the Yellowstone caldera written by a practicing Wyoming geologist. Contains a wealth of technical details on the geology of western Wyoming. External links, the Snake River Plain and the Yellowstone Hotspot, Yellowstone Volcano Observatory, YVOFAQ relating to supervolcano. Supervolcano documentary from BBC, interactive, When Yellowstone Explodes from National Geographic.